In the next couple of lessons, we are going to be dealing with something very, very important. We'll be looking at core concepts, the concept of LCM and HCF. Initially, what we'll focus on is, what do these LCM HCF stand for? How to find the LCM HCF? So what and how will be our initial focus? Subsequently, we'll look at few properties of it in one of the lessons, and then finally wrap it up with when we'll be taking LCM and HCF before moving on to questions based on LCM and HCF. So this is a framework for how we are going to be working with it. We'll start with HCF. The first part, we'll look at what is this HCF and then move on to the how. What is the HCF of 36 and 48? I'll start by listing down factors of both 36 and 48. 36 factors are as follows: 1, 36, 2, 18, 3, 12, 4, 9, and then 6. So these are all the factors of 36. Recollect how we used to list down factors when we are checking whether numbers were prime numbers. Do them in pairs. If you list down a 1, do a 36. Similarly, for a 48, if it is 1, it's going to be a 48. 2 is a factor of 48, so will 24 be. 3 is a factor of 48, so will 16 be. 4 is a factor of 48, so will 12 be. 6 is a factor of 48, so will 8 be. So these are all the factors of 48. The next step, let's list down common factors because we're trying to find out common factors for both these numbers. Common factors of both these numbers: 1, 2, 3, 4, 6, and 12. The largest such common factor, the highest common factor, is 12. So quickly, what is this HCF? Pick factors of number A, pick factors of number B, pick factors common to both. The largest such number is the highest common factor. It's also called the GCD, which means the greatest common divisor. So now that we have covered what HCF is, let's move on to how to find the HCF. One method is what we have done. We just listed things down, but obviously it's very tedious. You can't do it in an exam scenario. There are two methods to find out the HCF. Actually, more than two. We'll be focusing on only two. We'll look at the first method, which is the prime factorization method. As you would have guessed by now, when in doubt, just prime factorize numbers. That will tell you how to go about things. Let's start by prime factorizing both these numbers, 36 and 48. 36 is a 4 into 9. 4 is not prime, so we'll write it as 2 square, and 9 is not prime, we'll write it as 3 square. For 48, it's a 16 into 3. 16 is not prime, we'll write it as 2 power 4 into 3. So we have prime factorized both 36 and 48. Let's pick one of these numbers. Let's start with the 48. Let's focus on 48 right now. The prime factors of 48 are 2 and 3. 48 is a 2 power 4 into 3. Let me pick an f and let me say f is a factor of 48. And let's assume for a moment that this f is equal to 2 into 3 into 7. Can f be a factor of 48? 48 divided by f, right? It's going to be 2 power 4 into 3 divided by 2 into 3 into 7. Obviously, the 2 can divide 2 power 4. 3 can divide this 3. But the 7 cannot divide a 48 because there is no 7 in 48. So the first inference is that any factor of 48 will have only prime factors that are 2 or 3. So in other words, a factor of 48 when prime factorized will have either 2s or 3s as its prime factors. So if 48 contains only 2 and 3, no factor of 48 can contain a prime factor other than 2 or 3. 7 or 11 can never be a prime factor of a factor of 48. Now, the second question is, what is the highest power of 2 that can divide this 48? Can a 2 cube divide it? Certainly yes. Can a 2 square divide it? Obviously yes. Can a 2 power 5 divide it? No, because a 48 is a 2 power 4 into 3. A 2 power 5 cannot divide a 2 power 4. So, what is the highest power of 2 that can divide? It's the highest power of 2 that's contained in 48. So, inference number 2. The largest power of any prime factor that can divide a number is the largest power of the prime factor that you find in the number. Now let's take this to use it with two numbers together. 36 we have written it as a 2 square into 3 square. 48 is a 2 power 4 into 3. Incidentally, both these numbers have only 2s and 3s as prime factors. So any common factor to 36 and 48 cannot have a prime factor other than 2 or 3. Now the next thing is, the highest common factor of both these numbers will have 2s and 3s in so many powers as the highest power of 2 that can divide both the numbers. The highest power of 3 that can divide both the numbers. The highest power of 2 that can divide both the numbers, 2 square will divide 36, 2 square will divide a 48, but a 2 cube or a 2 power 4 will not divide a 36. So the highest power of 2 that can divide both these numbers is a 2 square. So the HCF is going to contain a max of 2. The HCF will contain the maximum power of 2 that it can contain will be a 2. The highest power of 3 that will divide this number, there's a 3 square and 36, but there is only a 3 power 1 and 48. Therefore, the highest power of 3 that can divide both these numbers is a 3 power 1. So HCF is nothing but the product of these two, which is equal to 12, which is what we got by listing down to. Just basically summarize this in the next slide. Prime factorize both the numbers in this method. We got 2 square and 3 square, 2 square into 3 square for 36, and 2 power 4 into 3 for 48. Now pick those prime factors that are common to both, because only those numbers will be able to divide both. In this case, the common prime factors are 2 and 3. Any other prime factor cannot be a part of the common factors list. Now to find the HCF, we need to find out the highest power of 2 that can divide both these numbers. That's going to be a 2 square. Similarly, we'll have to pick out the highest power of 3 that can divide both these numbers. That's going to be a 3 power 1. So the HCF of both these numbers is basically 2 square into 3 power 1, which is equal to 12.
Check out the related videos and remember to subscribe to the channel. What's more, let's make scoring Q51 GMAT a reality. Sign up for the most comprehensive and affordable online GMAT quant course at gmat.visaco.com. That's again gmat.visaco.com.